part 2 video of voting methods. Both of these videos cover 14.1 and 14.2 in your textbook. The third voting method is plurality with elimination. The rules state this: each voter only gets one vote, so they can only vote for one candidate. If a candidate receives a majority of the votes, meaning 51%, that candidate wins. If no candidate has a majority, then you cut the candidate with the fewest votes and have another vote. You repeat this process until the one candidate receives the majority of votes. As an example, this one here is talking about the math club. It says, let's see how the plurality with elimination method works when applied to the math club election. All right, so here we have some results. These are the first place votes, second place, third place, fourth place. If you look at this table, that means that 14 voters voted A first place, B second place, C third, D fourth. 10 voters voted C first, B second, D third, A fourth. Then you can go on with the rest. All we have to do is we have to first of all count the number of first place votes for each candidate. And so when we come here, here's the first place votes. A got 14 first place votes, B got 4, C got 11, D got 8. All right, if we divide this, if we add 14, 4, 11, and 8 together, that's going to give us 37 total voters. Okay. If we take 14 and divide by 37, not 50% or better. If we take 11 and divide by 37, not 50% or better. So we have to eliminate the individual who had the worst first place showing, which is candidate B. This is what they're showing here. So we eliminate candidate B, we have another vote. When we have another vote, letter A did not get any more first place votes. C did not get any more first place votes. The 4 first place votes that B had went to D. Again, we don't have a majority. So we got to eliminate C. We have a vote between those two, and we can see that letter D gets the majority of the votes, 23 out of 37. There's our winner. There's an example of plurality with elimination. Our last method, voting method, is pairwise comparisons. The rules are this: voters rank the candidates. In other words, you put the person you want as first choice, as second choice, as third choice, as fourth choice, so on and so forth. You run pairwise comparisons with each candidate matched with every other candidate. As an example, if candidate A beats candidate B in a comparison, candidate A receives 1 point, candidate B receives no points. If there is a tie, each candidate receives a half a point. Candidate with the most points wins the election. If we come over here, here's our example with a pairwise comparison. Again, we're going to use our math club example that we used before. You've seen this chart before where A has 14 first place votes, C has 11 because that's 10 and 1, D has 8, B has 4. So what we do is we look at all the possible combinations. If we compare A to B, A has 14 points, B has 23. See what happens when we compare first place votes or do a comparison. Here A has 14 first place votes, so it's done. And A is ahead of B. Here what happens is A or B is not here, so we keep moving them up until we get an A or a B. First thing we get is a B, so that gives B 10 first place votes. Here we move up, we get C. We move up again, we get B again. Here we have B again. We do it again, we get B. So B, actually, after moving things up, we get 10, 8, 4, and 1, which is 23 first place votes. That's the reason when we do a head-to-head comparison, B beats A. If we do A to C, C beats A. If we do D to A, D beats A. If we do C to B, C wins. If we do D to B, B wins. If we do D to C, C wins. Again, let me make sure you understand that if we're doing this pairwise comparison, we have to compare first place votes. So like again, let's compare C to D. All right, so in this case, we'd have to move C all the way up because we're not looking at A or B or D. And C becomes before D, so we're comparing C and D. So C would get a 14. C would also get 10, which is 24. C would also get another 1, which is 25. D, however, would get 8 and then move up and get 4. C would be the winner because C would have 25 and D would only have 12. And so looking at this, B, if we had B's points up, B has 2 points, C has 3 points, D has 1. C is the winner because they have the most points from the pairwise comparison. Section 4.2, we talk about flaws in voting methods. We have what we call a majority criterion, a head-to-head criterion, a monotonicity criterion, and an irrelevant alternatives criterion. When we look at the majority criterion, it says that if a candidate receives a majority, more than 50% of first place votes, that candidate should be declared the winner. So what they're saying is this is all mathematical. They're saying that based on math, if a candidate does receive 50% or more, at least over 50% of the votes, they should be the winner. This doesn't always happen. And so as a consequence, we got to be prepared to make adjustments either by changing our voting method like pairwise comparison or plurality with elimination, because we can use a combination of the different voting methods. Head-to-head criterion says if a candidate is favored when compared head-to-head with every other candidate, that candidate should be declared the winner. Now, this one here is a tough one because as you saw in the previous example, if I flip this back, you can see that even though letter A got more first place votes than any of the other particular candidates, when we do a head-to-head comparison, we got to keep moving things up till we get one of the two that we're comparing in the first place. B actually beats A because if you look at the voting, just because A got the most first place votes, if you look at the other voters, they considered A the worst candidate because they were all their fourth place vote choices. This happens a lot. You got to be careful with it. Another example of criterion is monotonicity, which says a candidate who wins a first election, but let's say they don't get the majority, then gains additional support without losing any of the original support, should also win a second election. What they're saying here is that, like in our example that we just talked about, the math club, letter A had the most first place votes. If we eliminate individuals and did a second election, math says that letter A should become the winner because letter A should gain more votes. And the last one is irrelevant alternatives criterion. If a candidate is the winner of an election and in his second election one or more of the other candidates are removed, the previous winner should still be the winner. All right? Again, this is all based on math. This is what pure math tells us it should happen. But unfortunately, we're dealing with human beings and things change. So we got to be prepared to have a second option. That's the reason we have so many different voting methods. I can use one particular method in the beginning and change my method in the end, as long as my rules are stated in the beginning. I cannot state it during an election. The process must be stated before I start the election. The thing I want you to see is this formula here. When you're doing pairwise comparisons, you can use this formula, which is saying combinations, that's what the C stands for, equals N, which is the number of candidates running for an election, times N minus 1 over 2. This will tell you how many possible combinations you should have. See, in other words, if we have 5 candidates, we should have 10 possible combinations. Last thing is I want to refer you to page 879 of your textbook. And this gives you the different voting methods on the top. And in the column at the left, it tells you the criterion. And it says, if I'm looking for the majority criterion, plurality method always satisfies that. But this may not satisfy it. This always satisfies it. This always satisfies it. If we look at head-to-head criterion, may not satisfy, may not satisfy, may not satisfy, always satisfies. If we look at monotonicity criterion, always satisfies, may not, may not, may not. If we look at irrelevant alternatives, may not, may not, may not, may not. This concludes 4.1 and 4.2.